Hello again, chemistry friends, Mr. Tro here. We are going to do the writing and balancing chemical reactions lab. It's a very quick process that I'm going to go through with you. Basically, I'm going to be mixing different chemicals together, and we're going to see what kind of products they produce. I'm going to show you the chemicals here in just a second, and we can talk through then what the procedure would be like. Okay, so what I have set up here is I have 4 sodium-based chemicals on the left-hand side: sodium sulfate, sodium hydroxide, sodium phosphate, and sodium carbonate. And then along the top side here, I have a bunch of different types of solutions: silver nitrate, lead nitrate, calcium chloride, iron chloride, magnesium sulfate, and copper sulfate. Now, if you notice, they make a nice little 6x4 reaction matrix. And these are called well plates. And so I've got a well plate here, 2 of them side by side, matching up. And basically what we're going to do is, in this lab, we're going to mix every iteration of these chemicals together, okay? And then we're going to go ahead and see if they produce a product. Now, at the same time you're watching the lab, you should have the lab open on your device. And you can see that there is a data table right here that completely matches up with the chemicals that I'm going to be mixing together. So it's in the same order. So if we talk about sodium carbonate mixing with silver nitrate, that's going to be reaction number 1. You can see we labeled it number 1. And that would be what we see when we look into this well right here. Okay? Now, after I mix these chemicals together, there's going to be a couple possibilities that would happen. Number 1 is that maybe they don't react, and that's possible. It's possible that chemical 1 and chemical 2, when they put together, there's no benefit for them to react, so they don't. And so you wouldn't see much of a difference. If that was the case, then in our table, we're probably going to write something like no reaction or the initials NR. But for most of them, what we're going to see is there's going to be a reaction that occurs that creates some sort of a product. Now, in this case, the product is going to be a solid. And we have a word for a product that's a solid. When you mix 2 solutions together and you get a solid, the solid kind of falls out of the reaction, similar to the way that, say, water, rain, or ice, sleet, snow would fall out of the atmosphere. And we have a name for that in terms of sleet and snow. We call it precipitation. Same thing in chemistry. So if we see a solid formed, that's technically going to be a solid precipitate, or there's going to be a precipitation that occurs. Our goal in the lab is to not only identify that, but to also identify its color and texture. So we might say, oh, it's a red, grainy solid, or maybe it's yellow flecks, or maybe it's white and milky. We're going to describe it as well. Okay, so hopefully we can see it well with the camera, and I will also try to give you a little bit of insight on what I'm seeing here in real time. Okay, so here we go.
Okay, you might notice that I changed to blue well plates, and that's simply so there's a little more contrast in case we see a white precipitate. It's probably easier to see it that way. Okay, we're going to take sodium carbonate, and I'm going to do this the most efficient way I can. I'm just going to put 4 drops in each cell. Might as well fill up all the ones that are going to have that chemical all at once. And now we'll do silver nitrate. So we can see that there is a white solid there, kind of a white specks. You can see individual small white specks of solid. Okay. I'll get a close-up of these later. Let's do lead nitrate with the same substance. There's also a white solid, but it's more cloudy. It's more of a white cloudy precipitate. Calcium chloride. Okay, very slight, but there is a kind of a hazy, tiny little white specks. So it looks like carbonate must like to make white precipitates. Let's see if that continues. Well, you're going to use iron chloride. Oh, we see something different now. Okay. Magnesium sulfate. don't see anything there. And copper sulfate. Okay, so there's another very faint, almost a powder blue solid. Powder blue, very fine solid. Okay. And the iron chloride formed a red solid. Okay, let's move on to sodium phosphate. We'll do every square or every cell. And we're going to see if phosphates like to create precipitates. So let's do the same 6 chemicals with that solution. So here's silver nitrate. It's a yellow solid, yellow specks. Lead nitrate. That's a white solid. It's actually more milky, right? So it's like a white, swirly, milky substance. Calcium chloride. That also forms a white solid. Kind of chunky, a chunky white solid. Iron chloride. Now, I am colorblind, so I'm not exactly sure what that is, but you might have to identify that one yourself, to be honest with you. I don't know the color of that. It's not white. It's also not yellow, or pure yellow. So we'll zoom in on that a little later. Magnesium sulfate. A very fine white solid. Copper sulfate. Okay, very fine as well. Let's move on to sodium hydroxide. Okay, sodium hydroxide with the same 6 chemicals. Looks like it has a brown solid occurred. Lead nitrate. Just a white flecks. Calcium chloride. It's very hard to see, very faint, very, very faint. Tiny little grains of solid, white solid. Iron chloride. A brown solid. Magnesium sulfate. Nothing. And copper sulfate. Nothing there either. Nothing there. Okay, last run, sodium sulfate. We're going to see if sulfates tend to form precipitates. Again, same chemicals. Doesn't appear to be anything there. Lead nitrate. Oh, disregard. I spilled a little, so disregard that. Definitely a white chunky solid. Calcium chloride. Nothing. Nothing. Iron chloride. A very faint, hard to see the color in the blue background, so we'll have to come back to that one a little later, but there's a very faint solid in there. And then magnesium sulfate. I don't see anything there. And then copper sulfate. I don't see anything there.
Okay, now zooming in, right? This would be reaction 1. I'm going to show you reactions 1 through 6, nice and close, and you can see the tiny specks and the color maybe a little better. There's 3, there's 4, 5, and 6. Very tiny specks in there as well. Here's 7, 8, 9, 10, 11, 12. Here's 13, 14, 15, very faint, 16, 17, 18, you can see swirly solid in there, almost a milky, And then we've got 19, 20, 21, 22, 23, and 24. Now, if you remember, when I started mixing them together, I talked about how I switched to blue well plates to see some of the colors a little better. That really helped with our lighter colors, like the whites and stuff like that. But some of the darker colors, it's really hard to tell what they are. So I'm gonna do the reaction again off camera. I'm gonna do the whole reaction set again off camera with the white well plates. And then I'll zoom in on them so you guys can see. That way, if there's any questions in our data table, we can use the second experiment to filter out some of the questions we had, okay? So let me do that. Okay, we zoom in now. Reaction 1, reaction 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, and 24. So those are the overall colors with a white background. And then right below them, those are the overall colors with a blue background. And here they are together. Okay, so hopefully you have enough information now, and you can pause the video and go back and look if you need to comment on whether there was a precipitate or not, and if there was, what color it was and what consistency it might have been, whether it was flaky or little tiny grains or milky or cloudy. That should all be included in your data table. Okay, so now that we're done with the lab, you should be in a position to complete the analysis portion on the backside. Your teacher will go through with you the process of how to predict the product or the products that were produced, how to write their formulas, how to balance the equation, and you'll do that in class and hopefully be able to complete up the backside of the lab. Okay? This is Mr. Tro signing off. Take care. I'll see you later. So I've let these sit overnight and the water has evaporated, so now you can clearly see the solid that's left behind. So as I mentioned earlier, I'm on the analysis portion of the lab. This is page 2. You should have already filled out your observations for the chart on page 1. It says here in the analysis portion that we're going to identify which reaction is occurring and write the reaction number. We're going to take a look at this very first one. And if I look for sodium phosphate and calcium chloride in my reaction, sodium phosphate, calcium chloride, where do they meet up? They meet up at reaction number 9. So that's an easy part to fill out. This is reaction number 9. Determine the products through these double replacement reactions. Now, depending on how far you've gotten in class, this could be a review for you, or this could be a little bit of a teaching session for you. But remember, with a double replacement reaction, we think of having two positive parts of compounds, and then we have two negative portions of compounds. And in a double replacement reaction, the positive is going to come over and kick out the other positive, similar to if a boy is dancing with a girl. One boy comes over, leaves his partner, asks if he can dance with the other girl, and then that guy that gets kicked out continues on and sees the other girl by herself and dances with her. So it's similar to that. In order to understand that, we need to look at our charges. So you can use your periodic table. I trust everyone knows how to do that by now. To look up the charge on sodium, sodium is +1. The charge on phosphate, polyatomic ion, is -3. The charge on calcium is +2. And the charge on a chloride ion is -1. So given that the positive is going to replace the other positive, we know that sodium is going to come over and kick out calcium, and calcium is going to replace sodium. So in that case, calcium is going to come over to the left, and calcium now is going to be paired up with PO4. So I write calcium and I write PO4. I don't worry about subscripts yet. I just write the positive and the negative together. That means that sodium is now over on the second compound, the new compound. You're going to have sodium matched up with chlorine. Now notice, I am not automatically transferring over subscripts. There was a 3 on the sodium. I didn't automatically transfer it over because when sodium bonds with phosphate, it takes 3 of them to match the -3 phosphate. But that may not be true when sodium bonds with something else. So over here, we need to take the exact same charges that we had on the left side and apply them over to the right side. So if you look, calcium still has a +2 charge, phosphate still has a -3 charge, sodium still has a +1 charge, and chlorine still has a -1 charge. Well, we spent a unit learning how to write formulas. +1 and -1, those cancel out, or maybe you learned the crisscross method. Turns out one of each is all you need. And so NaCl is a perfect compound. +2 and -3 do not cancel out. Turns out you have to get to a positive and -6 charge to cancel out. Or maybe you learned the crisscross method. Either way, it brings you to a compound that's going to have 3 calciums and 2 phosphates. And remember, we always erase the charges. The charges do not exist on compounds. Okay, so that's step 3 here, writing the correct formulas. Then we're going to balance the equation, and we should be able to do this by now. You make your chart down the middle if you need to. Your chart would be sodium, PO4, Ca, and Cl. And we would count them up. I've got 3 sodiums. I've got 1 phosphate. I've got 1 calcium. I've got 2 chlorines on the left side. I've got 1 sodium. I've got 2 phosphates. I've got 3 calciums. And I've got 1 chlorine on the right. And then you would go through the process of balancing it. I can balance sodium by putting a 3 here. Okay. That's going to make my chlorines a 3. And that doesn't really help me out with chlorine, but it's okay. I take this one step at a time. If I look at phosphate, I can balance phosphate out by putting a 2 here, which gives me 2 phosphates. And then I quickly see that, maybe I shouldn't have started with sodium, but it doesn't matter. But sodium is actually 6 now. So I took a little bit of a false step there, but that's okay. No problem. Calcium. I can fix calcium. I put a 3 here. That's going to give me 3 calciums. It's also going to give me 6 chlorines. And then I can fix this whole debacle I had over here with the sodium chloride. I need 6 sodiums, I need 6 chlorines, I can put a 6 there. So it doesn't matter if I have to redo something that I did before, as long as ultimately I get the reaction balanced. Okay? And that's the process you're going to go through for each of these reactions on the back side. Okay. Step 5, identifying which product is the precipitate. That'll be up to whether your individual teacher wants you to go through that or wants to go through that with you, but you should definitely do steps 1 through 4.